Okay, good morning. Good morning, everybody. Maybe I'll continue very shortly with the missing part of the robot saga, and maybe with the fairy tale, the three sisters. But I took like a break now after several hours of doing all sorts of stuff. Just and prepare another sample of the the work of the one-eyed snake, with fresh sample with my semen, and so I've taken three drops, very small samples of this semen, just to see what's in it, because yesterday we had kind of interesting stuff to say, but we also had intervention by the Israelis, they did online image processing, and we've seen all sorts of ridiculous stuff, you remember no neurons at all, but many geometric lines that obviously cannot be there and shouldn't be there, and this is the byproduct of online manipulation of the data, video doctoring of the data, and we've also seen non-fit information, and information that does not fit the kind of sample, and also sperm cells that I don't have at all. With together with neurons, and that's something that doesn't make sense. But of course, this is all doctoring of AI doctoring. Hacking the phone, because I use the phone for photography, and hacking the phone and doing online filtering and manipulation of the visual analysis. So let's now very quickly review the three samples that I've just taken from a fresh sample of my semen. Very small, three drops that I've taken, just for a quick review of what you can see in these samples. Shouldn't be too much of a hassle, because just very quick review. Oh, but we need, so it was kept on the microscope, so we need to put the charger, because no battery left. So just a second, I'll do it just in one moment. Just a second. Okay, so now we have the DC. It's very simple, 1 ampere 1 volt charger, and we have the LED light, which is fine. Just a second. Okay. So this is where the slide starts. So where are the neos? Yes, so now we see a little bit of them. Yes. Okay. So we see some, small ones that are typical. Maybe you should zoom in. Like let's locate like an interesting one and try to zoom in. Maybe so maybe here. So now it's 150. So we see neos, definitely. Not big ones, but they are never big like inside of like just a simple like Semen sample. Oops. Let's zoom in even some more. The really huge ones are all we can always see it like on like an ecosystem, like when they had time to grow significantly, and so then there we see the very huge ones, like the very fair, like, or alternatively, if they were taken from the electrolysis chamber of the crucible, that is the alternative path for the creation of like of the multiplying and the growing of the neros. It's kind of like an alternative path, and although you see very large one, but in semen and pee and things like that, like fluid, you don't see very big ones, but normal ones. The microscope is very jittering, especially in the maximum zoom level, but you can see neros, definitely. This is a nero. Like a small one, but definitely a nero. Okay, let's get back to 64. So we see all sorts of neos, especially thin ones. That's nice. Okay, not particularly interesting. Just it was a very quick review, but let's have like a very quick review of the two other ones, even though probably they won't be as exciting. But just for the record, okay. Okay, so these are neos, very nice. We see one next to a life form that is completely hollow, which is very typical actually to that. It's kind of like typical because probably this is the guy that actually made it hollow. You see the neo, the hollow life form? So we see all sorts of like neros, big, I mean, mostly small, I mean, but you know, small, more, so it's pretty, I mean, you know, uniform. It's not something very, nothing really to say much about it. Just, I mean, let's take a look, I mean, just, you know, in order, so, you know, to be rigorous, let's take a look at the third one. So this is the third one. Really, yeah, let's just, I mean, you know, very quick review, no, not even of the whole slide. I mean, just, I mean, you know, just the middle of it. So we see all sorts of kind of, you know, neros in all sorts of like shapes and sizes, and this is a pretty big but a completely hollow like form, like what I call a zombie. You see, this is obviously a zombie in the vicinity of all sorts of like neros. Okay, I mean, you know, as you can expect. So now I will just, so with your permission, I'll do like a bonus fourth slide. Slide number 4, which will be, I didn't prepare it in advance, so I'll prepare it with you. It will be the bonus slide. And I mean, if you've seen like the videos from yesterday, you already know what will be the bonus slide. Yes, it will be the Terminator slide, you know, the Terminator style slide, like with blood from my hand. So let's do it. Just a second. Maybe it will be more comfortable like that. Okay. Yes. So we take it from you see the hand. Yes, right. I mean, you see my hand. So we'll take it from here. You know, the place that, I mean, supposedly, I mean, you can measure like how, I mean, like the level of, like, I mean, how, like, done, like, well done or medium of the steak, you know, I mean, how it's, I forgot how it works because I don't eat steak for many years, for several years now, but, I mean, it's like, I mean, a way to actually, you know, so there is kind of like a way that, I mean, to you know, to measure the steak, like, with that. Pretty barbarious to do it with a Japanese knife and not like, you know, but I mean, whatever. It's not that sharp, so I mean, I cannot like, you know, pierce the skin. So I think I pierced the skin now. Yes. Yeah, so, but just a tiny bit of that. I try to pierce the skin like many, like, so we get like a big drop, but not too big, I mean, so, I mean, because you don't need too much material. Okay. There is some blood here, but I mean, yeah, yes. I mean, just let's take another one, like one small, like a cut, so we'll have like enough blood for a good sample. Okay, I think we're I mean enough with the cutting. Yes, good. So now just I mean just yes. So we have especially in the last one we had like I mean good red like a cut, you know, which is great. So I mean it's now all over the place. So yeah, we definitely have like a good like I mean good amount of blood here. But I think what I think happened is that the cover fell to the ground. So I'll take another cover because I mean I don't want to. I mean obviously the floor is really dirty. So this is the. Can you see this is the slide? I mean pretty. Yeah, because I cut myself like I mean eventually I mean yeah I mean there's pretty much like, maybe I'll add a little bit more. So yes, I mean that's about it. You don't need more than that. It's really good amount of blood. And now it's properly covered. Okay, so now let's take a look. So this is the blood. I mean, perhaps a little bit too much, but okay, never mind. It's very shallow. Don't worry. So now let's take a look at the blood sample. Again, we don't have. I mean, for blood sample, it's very helpful to use what stains like eosin Y and methylene B, which help very much. Like I mean, in identifying both like the neos, especially the methylene like blue, and the eosin Y, the red one is very good. I mean, helpful like for the seeing the outline of the synthetic blood cell, red blood cells that I have. I mean, you can see the blood cells. I mean, even without the stain, but it's very helpful to have the stain. So what we see here is, of course, like I mean, dense, like a sample that is very dense in red blood cells, and that's why the neros are so shining, because I mean, it's like the Stargate effect. I mean, if the mixture is very dark or relatively dark, so the light shines through the nero like through its Stargate, and this is I mean, it's very very nicely. I mean, it's like very sharply seen, like very nice. It's like I mean even like higher magnification. So this is actually the mixture, and you see the red blood cells moving. They are not. I mean, you don't see like I mean, you cannot without eosin Y, you cannot really see like I mean the tube outline of the red blood cells. I mean, of course, it's not really red blood cells. It's kind of like a synthetic counterpart. But I can tell you that if you use the stain, the eosin Y, you really see like I mean the tube shape of the these like synthetic red blood cells, and I mean, and you see that I mean that they flow like I mean in 3D space, like so it's kind of like I mean they have all sorts of like orientations with regards to I mean to the eye of the viewer, as opposed to the neros that are also tube-like creatures, but they are always aligned, probably to the magnetic field of the Earth, because this is a very well-known property of materials that are known to be type 2 superconductors, that they align themselves to the magnetic field, and presumably in our case with magnetic field of the Earth. So that's why neros are always aligned, like whatever I mean, all the neros that you always see, I mean, they're always aligned to the same plane. Unlike, again, like the red blood cells. Like both of humans and the red blood cells that you could see here, even though without the stain it's difficult to actually I mean, get a good look of like the tube outline. So this is again 64 magnification. We see very nice neros. So certainly the blood of a cherub with, I mean, you know, everything is to be expected, the neros, the red blood cells, the lack, I mean, the starking lack of white blood cells, because neros, I mean, they are doing the job of the white blood cells. Nice, like a smiley. Let's zoom in into it. It's very nice. Yeah. So actually 3 neros, not 2. Very nice. Okay, so I mean that's nice, really nice. So okay, so that will be all for now, and maybe I will continue with. I mean, like I'm feeling like a lack of energy. Maybe I need encouragement, like I mean, fan letters or maybe money, you know. But I'll try to continue. I mean, to finish the saga of like the robots. We don't have much left to say about it, but it should be said whatever that is left. And also it was regards to my own part, like in the last couple of decades, very briefly, and then I'll continue with the fairy tale.